K-nearest neighbor is a supervised machine learning algorithm which is solve the regression and classification both type of problem. When you're talking about the definition of the K-nearest neighbor, so it's a simple algorithm that store all the variable cases and classify the new data points on the similarity measure. Similarity measure, if we try to find it out, we have to find it out the distance as well. So we'll also discuss about it, ki which distance and how we will implement it. So, before going to the understand the distance, we have to also understand that it make the prediction by looking at the k closest point. So, not to check with entire data, it is check the k values only. To choose the number of k, there is a techniques is also available, that is a cross validation and elbow method that we'll discuss in this video. So KNN we are also calling is a lazy learner because we are not using any kinds of discriminative function. So we can say it does not learn a discriminative function from the training data set. So meaning of the discriminative function is that we are not using any kinds of probabilitical concept. So this is the definition is also mentioned there. You can also refer it. So let's understand it how KNN is working. Let's say for example, I have a data point which is defined like this. Um, 1, 2, 3, 1, 2, 3. There is a two different classes are there, and I want to predict it one particular data point, which is this. So this will be belongs to which classes? Is a circle classes or a cross classes? It will take the distance from here, 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 and take the average. And it is again taking the distance from the second point as well, here, here, and here. Take the average and then decide it. So which class it is the closest point. So later you will get the answer is like that the second point it will become a circle only. The new point it become the circle only and it will be the class. So conclusion of this story. So we have the new data points and we have to check the distance. So which category have the closest one, and later it will be classified. So here the question is how we will find it, how we will calculating the distance. To calculating the distance, and this is also one of the example I just mentioned there. So let's understand it how we can calculate the distance. We are using the Euclidean distance. I think we already learned. So let me just show you. Suppose you have a two different data points. One data point is here and the second data point is here. I want to find it out the distance. So let's say the coordinate of this data point is x1 and x2. X1 and y1, let's consider. Let's make it very simple, x1 and y1. Okay. uh, yeah, x1 and x1 and y1, and this one is x2 and y2. So this one we can say it's a x-axis, this is the y-axis. So x1 y1 in the sense this one will be the y1, this point will be y1, and this one point will be the x1. Okay, the same thing here. This point will be uh, y2 and this one point will be x2. Okay. So our target is to classify it. Our target is to find it out the distance from here to here. To find it out the distance, so of course, from here to here, it will be x2 minus x1, x2 minus x1, right? From here, x2, from here to here is the x1. The same thing, I have to also try to find it out because this distance I want to find it out and this distance I want to find it out. So that has become the Pythagoras theorem. So later it's become the distance. Let's consider this is nothing but a d. So d is equal to root of x1 minus x2 or x2 minus x1 to the whole square plus y1 minus y2 to the whole square. So this distance formula, I think you already learned in a 9th class and a 10th class, and here we were also using the same. But the discussion of the data science perspective, we don't have the only do 2 points. We have the n number of points are there, so we have to find it out the optimal one to decide it. So that's why three different types of function is available. The first one is uh, Manhattan, second one is Euclidean, Manhattan, Euclidean, and Minkowski. So Minkowski is a kind of the optimal one. Yeah, we can say it's a optimized way of the formula. So here it is xi and yi is a kind of, it's defined the data points. I is nothing but a number of rows, data points are defined. And based on the q is a parameter. Suppose the q, if you consider, you can see this is the definition of this one, is define it. And if you will just make it only the bar, then it's become the Manhattan. And Minkowski is the kind of the optimized way. In case if you're making the q is equal to 1, so what will be happen here? What will be happen here? The summation of I is equal, I start from 1 to k, and then this one become 1 upon 1, this bin become the 1 upon 1, and this one is 1. So at the end, your output will be xi minus yi bar. So that is nothing but a Manhattan. If you have a q is equal to 2, then it's become summation of I is equal to 1 to k, okay, and xi minus xi minus yi, and the q, it's become the 2, then it's become the square, okay, and this one become the 1 upon 2. 1 upon 2 is nothing but what? Is a root. So it's become the Euclidean. Okay, so let's conclude it. So what I have discussed, let me just conclude it here. So how the Minkowski, Manhattan, and Euclidean is look like. So here you can see the Minkowski is defined like this, and based on the parameter, it can be controlled. You can just make it in the Manhattan, you can make it in the Euclidean based on the parameter. So in practical implementation, when you're just doing it, so you'll also find it out in a library scikit-learn. The p-value will be available, and you have to pass it. By default is a 2, that is nothing but a Euclidean distance. So let me just clean it everything. So yeah. So Euclidean distance function we have discussed. Now it's time to discuss about it, how this entire KNN algorithm is working. So the first thing is that if you have a data set, let's consider, and we are in the supervised algorithm. So we have the X, and at the same time we have the Y is also available. So X, we are simply calling it's nothing but a feature. And this one we are calling the label. Okay, we are also calling the independent and dependent variables, but the data perspective we usually calling the features and label. So the first, we always load the data. Okay, so let's say for example some data points are available, and that rows is, let's consider it's 20 rows and 2 columns. Okay, this is nothing but a rows, and this is nothing but a columns. Okay, so 20 rows and 2 columns are there, and I have a new data points that I want to predict it. Okay, new data points, new data point. Let's consider the x is equal to some values are there. Some suppose 50 is there, and y I have to predict it. Okay, so this how this algorithm will work. So the first thing is that you have to load the data, your whatever data you have, the 20 rows and the 2 columns, you have to load it, and then initialize the k to chosen number of neighbors. So you don't need to calculate with the entire data, you have to choose, you have to work on only the kth values. So let's consider the k is equal to 5, not a big number, let's consider 5. There is a techniques to define it, to find it out the k values, but let's randomly decide it k, and after completing of these steps we'll also discuss how to choose the k values. And then for each example in the sense each row, for each row calculate the distance between the query example is nothing but a this, let's consider is this is nothing but a query example, and the current example from the data. From the each and every points you have to find it out the distance from there, and then add the distance, and the index of the examples in a order collection, because we have to also just take the indexes as well, because corresponding I have to also find it out the label. So the fourth step it will be, so sort the order. So whatever values you'll find it out from the 15 to all the 20 rows, you have to sort it out from the smallest two largest values. Let me just remove it. Um, okay. From the smallest to largest values. Smallest to largest values, we have to find it out. After completing up this, then we are going to find it out, pick the kth values. So when you just make it the order wise, so k value you have to pick it, not to entire values. So maybe the steps looks a little bit complicated for you, but practically really very simple. So we will also discuss about it. Let's quickly complete it. So then get the labels of the selected key entries. Labels in the sense that output, we have to get the labels. And then in case if you working on the regression, then you have to take the average. And if you're working on the classification, then apply the mode. Mode or voting basis, a most frequent values, you have to find it out. This is the steps, and practically we will also implement it. So in Python, we'll use it here. I'll just put some memes to just understand it how the KNN is working. You can also just read it and understand easily. I love my neighbor only if they are near to me. So that is the conclusion of the KNN algorithm. So let's also discuss about it ki how to choose the number of k. As I said that the k is equal to 5, we can find it out, but how to choose it? So when you get the y values, suppose y already have, suppose we have a 20 rows, right? 20 rows if you already are available, and you pass the predictions. Okay, you pass the prediction. That's, let's consider 20 rows, which is the true will consider, and 20 prediction, you'll also get it the prediction. So when you just apply the metrics here, okay, metrics, if you have a classification, if you have a classification, then you have to classification, then you have to use it confusion matrix. If you have a regression, then you can just use it anything, RMSC or R squared and MSC, anything you can just use it. So that metrics you have to find it out. So what you can do, so maximum entries, maximum k value will be 20, but you don't need to calculate it till 20 only. So we have to create one graph. Okay, here will be the key values, and here will be whatever. You can just take it accuracy or error. Let's consider the error. Okay, consider the error. Matrix will find it out. Let's focus on the confusion matrix and focus on the R squared. You will get the range is 1 to 0. In case if you have a accuracy, just 1 minus, you will get it error. If you have an error, you can also calculate it. 1 minus is you'll get it accuracy. So when you just calculate the error, and based on the your requirement, if it's a classification or regression, so k can be start from 1 and then 2, then 3, 1 is here, 3, 4, 5, 6, like this. So every time when you just increase the k values, your error rate will be decreased, and some particular points is become the kind of elbow. So you can see it's become the elbow. So here will be your best point. So I can consider the 4 is a number of k is will be the best points. So based on the k, it's also varies that how the classification is working. You can see if I'm just passing the k is equal to 1, and when I just pass the k is equal to 3 and k is equal to 5 and 7, how it will be changed. Okay, so you have to generate the graph and then decide it what will be the best k value for your data set. So the conclusion, it will be look like this graph that we are calling the elbow method. Okay, so again, it's a practical implementation. We'll discuss about it in a very deep, and there you can easily understand. So let's also discuss about it. What are the advantage and disadvantage of the KNN? The advantage is that is no training periods or taking it, and it's really very easy implementation and work well if you have the small data set and a low dimension. Low dimension means low columns or features. Okay, low columns are features. When you're talking about a disadvantage, disadvantage is that It does not work well if you have a large amount of data set, and the same thing does not work well if you have the high dimension. High dimension means high features of the data is available, right? And it's very sensitive to noisy and missing data. At the same time, it's also required to scaling every time, because this is not a probability based algorithm, it's a distance based algorithms are there. So it's also very very important question is that it is really required the scaling, feature scaling. So what are the types of scalings are there, that you can also refer the other videos. But here, so feature scaling is in interview perspective, the people are asking, it's really very important. Yes, the KNN is a distance based, so scaling is mandatory. If you're not using scaling, so what will be happen? So feature will be large volume, it will be dominate, and that's why we use the standard scaler or mean max scaler, anything you can use it. So regarding that, I just want to share some interview questions. Like first interview question is that why KNN is called lazy learner? Because there is no training, there is no computational happens at a prediction time. And the second, why scaling is required? As I already discussed, it's not a probabilistical based algorithm, it's a distance based algorithm. So you have to use a scaling. Okay. And how to choose the k values? To choose the k values, you have a cross validation and elbow method. And the last one, when not to use a KNN, of course, if you have a large data set and high dimensional of the data, you should not use it.
In the next video, let's start the practical implementation.